Okay, in this test, another few hours of printing, messing around. First printed up this one, but Dodo made the bottom level with the rest of it when we have a large step up here, so we had to go and print another one with the step up. So what we got in there is all our little keepers, transformer laminates that we cut in half. Trying to find the right box here. No, it's not that one either. Running out of boxes, so we'll get it sooner or later. You would think I'd be organised and have one ready, wouldn't you? Anyway, so there's a whole heap of these glued in here, all the way along up to this point here, and that is the distance between magnets on our rotor. So what I need to do, or what I wanted to discover and test with this setup, is we have a magnet on here. As you can see, this is where 3D printed parts start to fail, when you're trying to get very tight tolerances between the magnet and the core. So the gap in the center of the core is 11 mil and the magnet is 10 mil, so we're talking about 500 microns either side, and it tends to want to either pull it up or pull it down towards the core. But at the moment we may have it, it feels like it's sitting fairly free there, so that's good. So the magnet at that point there is the strongest pulling force towards the core, and we go through our little gizmo here into a set of scales. Now throughout this journey I'm just going to use the terms force. We're measuring things with scale, and leave the torque out because it got all too confusing and that sort of thing, as some of you might have seen in the other thread. So I'm going to be measuring the pull force here as it sits there into our transformer laminate gate, if you want to call it that. So I'll take 3 or 4 averages, and then I'm going to get another magnet of the same, and I'm going to place it in this end of the core, and so it's the same polarity, and see how much we lose on this pull force into the core. Now if we lose any more than 30%, we're starting to fight a losing battle. Haven't actually tested it, we're doing it live. So that's the plan here. We want to see as little drop in our pull force here when we put the other magnet in here, because that would represent the next magnet on the rotor that is leaving. So as we know, if we have a nice big heavy flywheel with this setup, the energy put into the flywheel from the magnet being attracted to the core is the same amount of energy required to get that magnet back out of the core at the other end, minus some small eddy current losses and bearing friction, that sort of thing. We're not worried about that because this is a static test. Obviously there's not going to be any of that. So I'm going to just put our little screwdriver in here, lever this back so the wire is loose, zero the scales, and then let it go gently, and take a measurement of the scale, see what it says. We'll do that 3 or 4 times so we can see that we're getting a reasonably steady average. Then we're going to place our magnet in the other end so the polarities are the same, and see how much we lose here. And this is very important, so the less we lose, the more powerful our motor will be. So this is one of 2 major tests that determine whether this is going to work or not. The second test comes where we've got to try and eliminate the 1 + 1 = 3 effect, and I believe we can do that because we're actually looping the fields of each rotor. Then they leave this loop and come face to face and repel. So that's the plan. So our next test setup, it's probably going to take me a couple of days to print the formers, glue in all our laminates, because we have to have two. One can be sitting static and we can just move that in and out, and we'll see how we go from there. Alright, so I'll set the camera up on the scales now, so you're watching that because you know what I'm going to be doing here. And then when I place the other magnet in, I'll just grab the camera, show you that it's in there, and then we'll do another 3 or 4 tests and see how we go. I'm getting constant 900s now. 905, 900 to 910. I'll put the magnet back in. The magnet is now back in. $900. I think the wire might have slipped into place a bit tighter as we were going. 900. $900. Well, it didn't seem to make a difference, so what I'm going to do now is, I'll switch it just there. Or maybe over here, so you can see what I'm up to. And I'm going to put another magnet in there. So now, not that you can really see, but we have 2 magnets in there now. I'll place it back over the scales and we'll see what happens. Starting to look pretty good at the moment. No difference. Okay, I think we're on the winner here. So with the 2 magnets now in the other end, I made the board a bit long, but I just grabbed what I had laying in the shed. So we now have 2 magnets, all the north poles on the top and all the south poles on the bottom, and even with 2 in this gap here, oh geez, they stick to this stuff good. 1, 2, does not change the pull force towards the core, and that is absolutely fantastic. Better than I had hoped for. So it would seem that the magnet in the rotor in this position leaving is not going to affect the amount of pull force the magnet on this next position coming into the gate has. That is absolutely fantastic. So that's that test done. Another test for the day. But what we've got to do now is make up a bucking situation and see if the 1 + 1 = 3 situation arises. I don't think it will, because we're actually looping the field of the permanent magnet through the core, and it's only going to become exposed once the 2 magnets leave the core on the rotor. When they do that, of course the north and the south field of each magnet still going to be attracted to the core, so the loop's still going to exist. So I don't think the 1 + 1 = 3 effect is going to take place in this case, and if it doesn't, we are on the road to making a successful magnet motor. But like I said, we're going to have to step up to machined aluminium rotors, because the plastic is just like that, and now it's stuck to the bottom. It's very hard to get it to sit in the middle, especially when it's got a little bit of movement here, but thankfully we managed to get it just right. So this is why we can't just 3D print one of these motors, because the tolerances between our core and the magnets has to be extremely fine to enable that field to loop completely, or almost completely, and the more we can confine that field of the 2 incoming magnets, the lot better the result gets. Alright guys, unfortunately work for the next few days, so it's going to be a bit of nighttime printing, so as we can keep this show on the road.